All right, there we go.
Where's my, there we go. Okay, welcome to the July 4th, 2023 session of Tangerine SDR and the Hamside technical session. My name is Dave, KV0S, and this week I've been continuing to work on K9 radio. I'm learning more and more about the intricacies and things that work and don't work and how to set things up. So it's a learning curve, but it's actually a very nice system once you get it going. So anyway, that's it for me. Next on the list is Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Dave. I was out at San Diego last week at the National Science Foundation CDR workshop, which stands for Coupling of Energetics and Dynamics of Atmospheric Regions. And that's the National Science Foundation program that funds the Personal Space Weather Station grants, both the original one and the one that we just got for the GRAPE Personal Space Weather Station and the eclipses. And so I was there with Bill Engelke and probably about 10 students, and my Rachel was there too presenting. So it was really busy. I think everything was well received. We had, with Gary McKeaton's help, we had some really nice slides that were rotating through the plenary session. So as people walked in the room, they just see these slides advertising Hamside, which was really nice. And then the NSF program officer, Dr. I can't say her name right now, but she, Tyen, Dr. Tyen Wang, she highlighted the Hamside workshop in her address, giving updates about the NSF program. So I think that was all very positive. All of the students who attended, they all gave posters, some of them on the Personal Space Weather Stations projects they've been working on, some of them on traveling atmospheric disturbances. I spent a lot of time talking about traveling atmospheric disturbances and the solar eclipse. Eclipses are coming up. Today, I spent most of yesterday and all of today working on the Frontiers paper, the edits. So there are minor edits that I was asked to do, but those minor edits still seem to take a very long time because I had to go back and review different things I didn't know all the details of and try to figure out how to wordsmith them and put them in. But I addressed pretty much all of the comments that reviewer 1 had and almost all that reviewer 2 had. So tomorrow I need to make a table that summarizes all the different research topics that amateur radio has been contributing to. And that's the last big thing reviewer 2 has asked for. And then I have to go back and make sure that everything is in within the correct length. So there's probably going to have to be some shortening, which is going to also take some additional time. But once I get through that, I think I should be able to get the revision submitted this week finally. And then Bob McGuire is N4HY is supposed to be visiting the University of Scranton this week to work with my student Gerard on Ionoson project that we have going. So there's a lot of balls in the air. There's stuff going on with the GRAPE Personal Space Weather Station. We're trying to move ahead. There's stuff with the Traveling Atmospheric Disturbance Project, all this stuff, but it's all moving forward. So back to Nat.
Well, very good. And you've been a busy fellow since the last month and a half.
Yep.
Next on the list is Bill, AB4EJ. Go ahead, Bill.
Thanks, Dave. Well, last week, as Nathaniel said, was spent at the CDR conference. So the only thing I have to report was week prior to that, I received an RX 888 SDR in the mail and started playing with that a little bit. I started an experiment to see if I could get it to run under Windows by, to use the KA9Q software by using the WSL Unix environment that runs under Windows. Was not successful in doing that. But we'll try it again with a box that has Linux natively installed on it as a next thing. So other than that, that's back to Ned.
Yes, it really depends a lot on the using the multicast correctly and using the system D commands correctly. So those two are the things that seem to throw people. So anyway, next on the list, we have Bob in 5 BRG. Go ahead, Bob.
Hello, everybody. I'm just here listening tonight. Not a lot to report. Back to you, Dave.
Okay. Next on the list is Dave Witten, KD0 EAG. Go ahead. Dave? I can't
Negative
hear-
audio.
I see Dave talking, but I don't see any, don't hear any audio. He had it working a while ago.
Yeah, that's strange.
Nope. We'll come back to you, Dave.
Who knows?
Oh, there you are.
It's working.
Go
Who
ahead.
knows? There, you can hear me now.
Yes.
Okay, I can't explain it at all. But let's see, I've spent the week, spent a lot of time lately just working on getting a schematic that can be used for any future purpose based on the HF 103, which is essentially the underpinnings of the RX 888. Though it's a kind of a simplified version, I'm trying to do the non-saponifiable minimum there somehow. But there's lots of, so I'm down almost to where everything I understand is in there, but there are I have several different schematics that I jump back and forth for reference, and there are lots of to be determined parts and lots of not used parts, and some that are just not labeled exactly. So there's lots of questions I would have. They're mostly kind of basic things that any radio designer probably, who knows more than me, would be able to help with. But so I want to get back to Franco and Tom, especially with try to tell me what these schematics were trying to do, and in spite of what they left off. But other than that, that's gone along for anyone who cares about that part of this thing. Not quite sure how important it is at this point, but I'm doing it. So I guess that's it for me.
Well, I, for one, believe it is a wonderful reference in that we'll have it. And if we want to build anything new, we can start with those. So next on the list, we have Jim, K4BSE. Go ahead, Jim.
Well, good evening, all. I'm pleased to be back after about 10 or 11 weeks off while I was teaching that extra class course down here. And we got that done. And I'm pleased to say that 9 out of 10 people who took the test passed it on the first try. And so that made me feel pretty good. But I'm finally back now, and I've been trying to bring up my magnetometer with Dave's help. And I've been a real tough customer for him, because I keep making mistakes and having problems that he has to bail me out of. And maybe in on another one now. But by the way, Dave, my background is RF design. If you need another pair of eyes to look at that, the schematic, I'll be happy to look at it for you. And that's about it. Getting back into the saddle after that, and missed our local 10-meter net this evening because we had one bodacious thunderstorm over the county about that time. So I wasn't there, and I don't think anybody else was either. That's about it from here. Back to Ned.
Very good. Next on the list is, let's see, David McGaw, N1HAC. Go ahead, David.
Hello, everyone. Speaking of bodacious thunderstorms, we've been having a long series of them the last couple of weeks. I'm surprised we aren't getting what I call the usual flooding, but rivers are running high and we keep getting it in waves. But other than that, been working on the AM Doppler project from our side, getting some new radios built, but also trying to define what new stations we'll be listening to, because we're expanding our footprint. We'll be listening to different stations than what we were just in the New England Northeast area. And then with the idea to disseminating that to the people who are interested in the medium frequency monitoring during the eclipses. Also doing assembly and documentation of our KGO project, moving ahead on that. And I guess that's, I do have an RX-888 on the way, since there seems to be a lot of development happening around that platform. So that'll be good to try out and be up to speed with where we are going with all that. And I gather the Clementine is coming along as well. So I guess that's back to net. Oh, and happy 4th already in UT.
Yes. Well, next on the list, we have Franco, K4VZ. Go ahead, Franco.
Good evening, everyone. A few updates. The first one is that Phil Kahn is back from Europe. He sent an email to me and Rob Robinet where he got 2 extra RX-888 and is working on a way to make KA9Q be able to support faster rates, because if you remember, or if you guys are aware, is only Phil is only been able to use 64.8 mega sample per second because of limitation in the way he transferred the data via multicast, and is working on a direct shared memory approach. He sent me an email on Thursday, I think, last week. So just an update for the group that it will be possible eventually to use it for 128 mega sample per second or something like that. First update. Second, a quick comment to what I think Bill was saying is that there is no way, I'll tell you already, no way to use the RX-8 with WSL. The reason is because of USB. So basically when Microsoft developed this WSL, they use some kind of VMs and they never thought or never put too much work into the USB part. And so the only way Microsoft can talk, Windows can talk to the USB part is via something called an IP hack or something like that. And there is no way they can run 64 mega sample per second, the kind of rate. So I'm happy to help you, Bill, if you need help with Linux, because I've been running Linux forever, but I'm afraid the only way to go that way. Speaking of Linux, there is another interesting development based on the discussion we had last week, where there is a program called RX-888 Stream, which is very basic, very simple, very low level, but it allows you to get the IQ samples directly from the RX-888 without any translation, quote unquote. So for instance, for an event like the Eclipse, you could think, hey, I'm going to run that program for those 3 hours, or what time it takes to cover that, save it to disk, with SSD disk, and later on you can run KNIQ radio, since KNIQ radio can use an IQ file and use that. So that's another interesting approach. I think it can be used. One more comment for Dave Witten is that Oscar is very nice guy. So if you have a question about HF103, I'd be happy to put in contact with him. And he's retired, so he won't really give you much help. But definitely gonna be happy to help to answer those questions you have, without scratching your head and losing your hair. So that's another thing. Last but not least, I've been thinking about an approach. I don't know if you guys saw at what's his name at the SDR conference, SDR Academy, the presentation on Maya SDR by Daniel Estevez, and he's basically able to run a 4006 FFT point FFT on the FPGA, which is the Zinc 7010, which is not really the greatest, but it works. Okay, I was thinking if that approach were possible to run something similar and being able basically to select only those FFT you need, those bins you need, and basically use that with a much smaller interface than a USB 3, basically using a simple gigabit Ethernet. And this a mess, it may be possible, but I'm still working in my head, and maybe I'll try to put something together of this idea that I have. Okay, I spoke enough. Back to Nat.
Well, very good. Sounds like you've been busy. So good. That's good to hear from you. Next on the list is Joe, W7LUX. Go ahead, Joe.
Thank you, Dave, and good evening, everyone. Been watching the grape. There was a pretty good flare. I think it was 2300 yesterday, and mine jumped all over the place. So it definitely had an effect. One of the RX 888s arrived here several days ago. Got it working with Windows almost immediately. Have not tried to get it working with Linux. I suppose that'll be a little more challenging, but we'll see what happens. And it's working with SDR console on Windows. I guess my question to the group is, what information, what data does Nathaniel want, and what's everybody going to be collecting? Gary sent me email asking about a second grape receiver, and I found my second copy. And actually, I have parts to build a third one if desperately needed, although I'm not real keen on building another one. But what information is needed? How are we going to record that stuff? I don't know anything about recording from an SDR. So maybe somebody has some ideas they could throw in my direction. Would very much appreciate it. Thank you, Dave.
Very good. Nathaniel, do you have any comments?
Yes, the plan is to record it in basically a spectrum. I think about 8 kilohertz of spectrum around the carrier for WWV. I think we're still debating whether we're going to focus on either 5 or 10 megahertz. It should be fairly straightforward in terms of operating a grape and getting the data to the main server. Bill Engelke already has a Raspberry Pi image that runs the digital RF software and will record the data and automatically send it up to his server. So we would be working on creating more images like that. So basically you just put that image in your Raspberry Pi and you're good to go. Maybe Bill wants to expand on that, or we can talk about it during the open session.
Yeah, there's enough discussion. We probably should wait till the open session because there's a lot to discuss on that.
Sounds good.
Okay.
Thank you.
Well, I'll finish the roll call then. Next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. It was quite a busy week for me, Nathaniel, and some other students. We went to CDAR. So what I did at CDAR is I did the first day is called Student Day. That's a student seminar, and I did a presentation, high-level presentation on VLF natural radio. Discussing different sorts of emissions and some of the details and the system that I built that's running at Nathaniel's house. Tuesday was my I had to do my poster presentation for the judges, and I talked about my poster. I also met the guys from Georgia Tech, and Georgia Tech is known for its low frequency radio lab. And they were four guys four students under Morris Cohen, who runs the low frequency radio lab and is quite the VLF rock star himself. So I got to talking to a PhD student and an undergrad student who both did VLF related projects. In fact, I sent the undergrad student data from my system. So he found out a way to find acoustic waves in VLF transmitter amplitude data. So I sent him some data from the Tonga eruption and the day before and after, just to see what he could find. So I spoke to him about that. I also spoke to Morris about using the data from his VLF receivers and also the receivers from Stanford. Apparently, you could use Python or MATLAB to convert the data and hopefully somehow keep the sample alignment to GPS time. I have to talk to him more about that, but if that's true, I could convert the data to VLF-RX tools format and do a lot of analysis there. So I'm quite excited to actually try that. And I was also speaking to the students, especially the PhD student, about the possibility of going back for my master's and PhD, working under Morris and doing some major VLF study. Overall, it was a really fun and amazing trip. I had a good time, and I learned a lot about upper atmosphere dynamics. There's quite a lot going on, and I learned quite a bit. One other thing I wanted to mention, there was a fellow who was an Aurora chaser. This was the a banquet dinner speaker. So he's an Aurora chaser. He chases the Aurora, and so he did a presentation about what his background and what he does, citizen science outreach with the Aurora. And he showed pictures and movies of what he's captured. So when it was over, I asked him, I said, I'm a VLF natural radio enthusiast, and one of my dreams is to be able to listen to dawn chorus while watching an auroral display. And I says, would you be willing to take a VLF receiver with you? And he smiled with the biggest smile, and he said yes. And the whole audience went crazy. So that was a very fun moment. So overall, very good trip. Now it's back to the VLF stuff. I'm working on the 3-channel system and the H-field receiver. So that's a priority right now. That's all I have. Back to the net.
Okay. Next on the list is Tom N5EG, and he has some test results, I believe.
Okay, good evening, Dave and the group. I managed to get a hold of 4 receivers, 4 of the Tangerine receivers, and have been testing them. The way this is a dual channel receiver, so it's got 2 RF inputs, attenuator relays, noise injection relays, filters, a dual ADC driver, and a dual ADC. All those digital signals come out of the board via this MEC 140 connector. I don't know if you can see it, but the gold fingers plug in like this. So the board plugs into gold fingers like this on the board. And I was having problems with my unit. So I got Dave's, Nathaniel's, and John Ackerman's boards. And Nathaniel, can I share the screen here?
Yeah, go right ahead.
Okay. So what was happening is I was missing some bits. Is this showing up okay?
Yes.
Okay, missing some bits, and the ADC can be programmed to output bit patterns, disconnect the analog part of the receiver, and just output bit patterns at 122 mega words per second times 2 channels. And every receiver that I used had missing bits, and every receiver had different missing bits. So I got a continuity tester. My DVM has a beeper, and when the leads make DC contact, it beeps. And I tested the 4 boards, and you can see 4 columns here on the right, marked Nathaniel, Tom, Dave, and John, and the serial number, and then the signal names. The top block of 15 is channel A. The bottom block of 15 is channel B. And the first signal, DCOA, is the clock. And then you'll see D0A, D1A, all the way down through D13 for a 14-bit receiver, and then the overrange bit. And the same thing on the B channel. And using a small resistor lead, I could touch just the end of the lead end on to the ADC pins under a magnifying glass, and then measure with another resistor to the connector on the data engine adapter board. But what I found is none of the 4 receivers have DC continuity for all pins through that MEC 140 connector. So the clock, for example, doesn't connect on Dave's and John's receiver, but it does connect on Nathaniel's and Tom's receiver. And that means that I can actually sample words on channel A on Nathaniel's and Tom's, but I can't get anything, of course, on Dave's or John's because there's no clock output. And then bit 0 is not connected on Nathaniel and Tom's. It is on Dave's, not on John's. And you can see that in no case are we ever able to get a clean channel through the MEC 140 connector for either A or B. So I was hoping to get at least one module that had a complete set of signals present for one of the 2 channels, and was not able to get that. So I can't actually measure any channel on either receiver on any module. So that was kind of disappointing. I'm now going to let me share a different image here, and that is this. Can you see it? This is a close-up of the MEC 140 connector. And that's the back end of it on the bottom side of the board, where it is surface mount soldered to the back of the receiver board. All the pins I'm having trouble with are the odd numbered pins. The even numbered pins are the ones you can see in front on the photograph. The odd numbered pins are the ones that are behind, and they cannot be observed and they can't be probed because there's no way to get any probe in there, and it's impossible to look around those front pins. All of the pins that are giving connection problems are odd numbered pins on the back of that connector. And so I'm kind of formed the hypothesis, what I think has happened is that there's not enough heat during the surface mount soldering operation to get the solder to reflow on the hidden pins in the back. I think they were shadowed too much by the connector pins on the front, and either they weren't left in long enough or something else. But if infrared was used to solder them, I'm worried that the shadowing of the front pins prevented the back pins from reflowing. And so I think that's one possible explanation. I asked if I could get a bare board so I can ohm meter from those contacts to the ADC pins, but I didn't get any response on that request. I also made a request to see if this modules could be reworked, and maybe we could salvage one by reworking that in an oven or with a hot air pencil or gun or something, but I didn't get any response on that. So right now, all of the boards are dead and not measurable through the fixture. And so that's kind of disappointing. So that was, it's kind of been the last 2 weeks, work, and that's it. We can talk more about it during the open time.
Okay. Thanks for all that work, Tom. Last on the list, we have Gwen. Win, sorry. Win A14MV. Go ahead, Win.
No, sorry. I'm just checking in for the first time. I live in central Virginia, about halfway between Charlottesville and Lynchburg. Just trying to get oriented in what goes on here.
Well,
Thank
you're
you.
welcome, and we're happy to have you here. If you find it interesting, please come back. Okay, well, that brings us to the end of the list, so we're open for general discussion. Tom, do you
first.
want to say something, or do we want to go? I think there were a couple other topics that we're also gonna.
Yeah, it doesn't matter. Why don't you hit them in order that you took them?
Well, since I'm talking to you, I'm gonna let you talk.
Okay. So the question is what we need to do. And if we could get the board reworked so that we can at least get a channel or two on one of the modules functioning, we can at least test the RF circuits, measure the noise figure, measure all those kind of things. I am getting a complete burst of samples successfully on the 2 modules that actually have working clocks. And those are coming out at 8 nanosecond period and going into a giant RAM FIFO in the FPGA. And they're coming out successfully, except for the stuck bits. And so I'm pretty confident that we're clocking things at 122.88 into the FPGA. So if we could rework a couple of the boards, and I think Scotty knows who assembled them, perhaps how they were assembled, we might be able to continue. If we can't rework the boards, then we have to decide what's the purpose of the board. I was hoping we might be able to use the clock module and the receiver boards and just plug them onto the USB 3 adapter, saving us a ton of work and just having a digital USB 3 adapter because the boards have I2C and SPI. And so the USB 3 chip would be capable of controlling it. And we could demultiplex the data out to 32 bits wide to get the sample rate down to 61 megs. So the USB 3 chip can handle that. If we're not able to test the boards or do that, then I think we have to back up and probably say, we're going to need to do our own receiver design or copy the RX 888 design, or maybe come up with a hybrid of the two. And so in my view, that's kind of the first question. Can we rework these things? And if not, then maybe that we're not able to really salvage much of that.
I
design.
take it you have not gotten an answer back from Scotty yet?
Yeah, I've not gotten any answers back.
Communication to Scotty is difficult right now because he's living in a trailer and he's in his only communication is with a cell signal, and he's halfway between 2 cell towers, almost exactly halfway between them, and they fight over his signal. So you can communicate with him if you call him at a time he's driving around town. But when he's at home, he can't get a signal and he can't really use the internet.
Maybe we could send him a Starlink system.
Really?
No, I'm serious. I mean,
No.
you can buy them from Home Depot.
Well, the other thing is that maybe he can get a beam antenna so he can be pointed at one tower.
Yes.
Tom, it should be able to be reworked. Even just with a hot air tool and pushing down on each of the pins. It may be able to, I'll take a look at the one that I have, see if I can see the defects.
Okay.
And I do have a hot air tool too. I might be able to actually play with it. The other thing one can do is take the whole piece off and then reattach it with hot air and whatnot.
Yeah,
There should be a way to rework it.
well, I was hoping there might. The inner row of pins, you really can't get to very easily. I was trying to get to them with a sewing needle.
Right.
But that was difficult too. I can't really see them with the optical aids that I have. Like the outer pins, of course, you can see easily. But those are
Right.
the
Of
ones that
course,
don't
those are the
have
ones that are
problems.
okay.
Right. And so I was hoping they might be reworkable, but I don't know how you do it.
Yep. But on the other hand, there are people who do. That's
Yeah.
their job. So, and I'm sure, well, given the stories I've heard Scotty tell, I'm sure there's some good people doing rework that he knows.
Yeah, so that'd be my preference if we could do that and get some test results and get something working. It might save us a lot of time and effort.
And as you point out, if you've got one of the boards that's passing the clock and is missing only a few bits, you may be able to get some usable results out of that, especially if they're lower bits that are bad.
Yeah, we're right on the edge. If we lose even the lowest bit, we're right on the edge of the E knob of the converter.
Right, but
so yeah, so there we may be able to get that. It would be nice if we if there were some things we could do, but I don't know who can do that. So that's
right.
kind of stuck there.
Well, more shall be revealed on that. And I certainly know there are people who can do it.
Okay.
So
I'll tell you,
Dave Whitten, are you trying to speak?
No, can you hear me? Yeah,
I saw you clicking your fingers.
I was trying to see if my microphone was working.
Oh,
And
okay.
I wanted to say something. I'm sorry.
Tom,
I'd
I
like
had a
to vote.
question. Is it
Um,
possible to remove the connector?
Yeah, but you have to unsolder simultaneously 140 pins and two giant straps. Yeah.
That's not very easy.
That's well beyond my skill level.
Yes.
Well, given a very sharp set of diagonal cutters, one might be able to cut it off and then put a new one on.
Oh, yeah.
Yeah.
But even given that, I know people who have done remarkable things with a heat gun. You know, he can do like a 200 odd pin BGA with a heat gun. So there are people who know what they're doing with these things. We just need to let them do their work.
I wanted to get a blank RF board so I could at least probe from the connector pad to the ADC pin, you know, and rule out something wrong with the circuit board. My gut feeling is because different boards have different pins that don't connect, it's probably not an artwork problem.
What is the maximum data rate on any of those pins? And what are you using LVDS or CMOS levels?
Using CMOS levels, the problem, we said it can run in either LVDS mode or CMOS mode. To run in LVDS mode, the board was laid out with 100 ohm differential traces, but you need a 100 ohm termination resistor. And it turns out the Max 10 doesn't provide those. All the Cyclone and the other FPGAs do, but the Max 10 doesn't. And so we can't terminate those signals. So I'm running it in the CMOS mode, and it seems to clock just fine at a 122.88 megahertz clock mode. There doesn't seem to be, well, of course, my scope's only 100 meg scope. So if there's ringing, I'd never know it anyway. But I mean, you know, the pins that fail the data test also fail the ohm meter continuity test.
I was just curious because I believe the USB or USB 3 device can operate in either of those modes as well. I don't know how well. And I didn't know if what kind of, but the connector is a question. You have to have something that you can, that won't radiate away all your signal, and still be able to attach to something.
Yeah, I'm on the ones where I get clock and data, they seem to be clocking fairly well.
Okay, it's good to know.
Yeah, just looking at the connector, it's not that difficult to get it off and then put a new one on. Of course, the problem is getting the solder on the inside pins. But the way it's been mounted, it's got two pins to the side that are holding it down. That's easily lifted. And then put a heat gun on that, it'll come right off. Anyway, I wouldn't give up on rework.
I
Okay,
was thinking that you might be able to dispense solder paste into the center area if you have a small enough needle and
Yeah.
some solder.
They're
paste.
tiny, tiny little pins. I see the problem. It's like
There
there's
was-
less space between them than there is for the pin, and it's, yeah.
I was puzzling over a little device that, what's that outfit, Micro something, that sells stuff for mostly elderly train enthusiasts, model train enthusiasts, and a mixture of other hobby model builders and things. And they have a funny little thing, mostly for decoupling cars, but it has a, I think it's like a screwdriver, but it has some kind of fiber optic light source that goes down, and maybe it brings an image back out. I'm not sure. It would be wonderful to have a screwdriver where you could view from near the tip as you worked. This would be one of those cases, I suppose.
Yeah,
But
I've got a pretty good microscope. I'm also going to take a look at it on that.
Yeah, I'd be glad to volunteer to rework one of them, Tom, if you don't find another solution. If you want to
Okay.
send it to me, I can try to rework it and send it right back to you.
Scotty, he had he knows the contract manufacturer who built the thing. And
Right.
And so I think they have fixed problems for him in the past. And so
Yeah.
I was hopeful that, they would be able to do a good job. I just haven't been able to get a hold of Scotty.
Right. And the reality is it's their problem. It's an assembly problem that they
yeah,
should be willing to rework for us.
Yeah.
the
that-
word
so-
is contract.
Yeah, but that's the thing is
Yeah,
that
to rework that today, the problem, of course, is those boards were made a year ago. And so flux and paste on those inner pins, if it didn't get melted, might not be, it might be too oxidized to simply reheat. and
well,
work.
again, it can be taken off,
Yeah.
repasted, and then reflowed.
You can
Okay.
put solder, you can also put flux in there to do that.
Yep.
I have a hot
There,
air- hot
but the
air
point,
blower.
the other point is this manufacturer, I'm sure, has run into this before and has their ways.
Yeah. Yeah, so at any rate, that, to me, I'd like to see if that could be done. Yeah, and I'd prefer to talk to Scotty first. And if we can't work that out, then we can get, Dave and Bob maybe can give a try at reworking the module.
Does anybody have contact information for Charlie? Scotty's partner?
Oh, gosh, that would be Dan in for.
Yeah, we probably
Mhm.
ought to get Dan to try to get a hold of him.
Last time I talked to Dan, he said he was having difficulty getting hold of Scotty as well.
Yeah, it's because of this cell phone
Yeah,
communication thing and his both his internet and his voice communications are over the same link.
Mhm.
Charlie has a LinkedIn page.
Well, if you could get a hold, Nathaniel, maybe get a hold of Charlie and tell him that, you know, it's on this contract with Zephyr and we'd like to get some things fixed. And can he get a hold of Scotty? Because he lives there.
Yeah, I can do that. Should I message him right now? Or did you want to try
No.
contacting Scotty again?
I would suggest that you just send a message to him to have Scotty get a hold of you.
Okay.
You're the person working, so we're presume that you're easier to get a hold of.
Yes.
And
Yeah.
and you have grants involved in this. So
I do. What I will do, I really want to get this paper published first. I'm very close to that. So I'm going to wait until I'm going to get this paper resubmitted, which should happen the next day or so, and get through the 4th of July. And then I'll try and
Okay.
get Scotty one more call, or try and reach out to Scotty one more time, and then I'll go to Charlie.
The other one is you can get a hold of Dan and he could get a hold of Charlie for you if
Okay. That sounds good. Yes, I agree. I will absolutely escalate, try harder to get in touch with them, but I am going to try very close to getting this paper done. So I'm going to get this through.
so the nice thing is we have some alternative solutions in the pipe work.
Mm-hmm.
And so at least for your eclipses, we should be able to collect data.
Yeah. So I mean the closest alternative is the RX-888 with the GPS disciplining in RX-888, right?
Yes.
Yeah.
Now,
I
I
agree.
was gonna ask Franco a question about that. I tried using a Leo Bodner on the pin that's labeled 27 megahertz. And I was
Yeah.
wondering, is that right?
Yeah,
That-
okay. So I look at the picture because do you know what's his name? Gwyn, I think, or someone I was talking to not long ago. He did the same, and there is a switch on the board that
There is a
is
jumper.
a jumper, right?
Yes,
Okay.
and I did use the jumper in, well, you know, one way says short and one way, if you
Yeah,
leave
it's
it
marked.
open, it uses the internal source, and if you short it, it's supposed to use the socket.
Right, and it's marked that way. The other
Yes.
thing is, are you running at 10 megahertz or 27?
Well, I tried it both ways. I changed and it didn't seem to work either way.
Okay, so I'll do this. I'll find the email. I'll get in touch with him. So because he was
Okay.
able to do it, I forgot if it was Gwyn or someone, but I can get you after this. I'll go back to my emails and send you the
Okay.
information.
Franco,
Because it would be nice to get that disciplined. And I
Yeah,
know
he was
that
able to. Yeah, and
I
let
know
me
my
see.
Post
GPS
that
is
for,
working because I
For the
use it
rest
on
of us who'd be
another
interested in that too.
radio.
Right, let me see. Who was it?
I seem to recall someone raising a question about the signal level coming out of the Bodnar, whether it was,
Yes, there is an issue with that, and I tried it 2 or 3, but I didn't seem to find the sweet one.
2 or 3 what?
2 or 3
Milliamps or something.
levels, dB levels.
Voltage levels?
Yeah, if you go into the Leo Bodner full screen, you can change those levels.
It's the output current, I think.
Output current, yes.
Oh, output current, but not voltage level.
Yeah, I was gonna make,
And there was an email saying that if you use the full amount, it was too much.
Rather not damage the 888.
Yes.
Okay,
Yeah,
so
I'll take a look at that. I've got a Bodnar and we'll be getting the 888. And
Yes. Well, and I have.
it may
two-
be a matter of feeding it. One question is, does the 888 terminate it in 50 ohms or not?
Yes.
If it does, then yeah, the current level should allow us to get the right level.
Now, Dave, did you ever find an 888 schematic, or is it only the other ones? Dave Whitten.
Well, nothing beyond, I think I sent you the schematic for the partials. I guess it's a full schematic for the 888, not the Mark II.
Oh, okay.
But I think I sent that to you.
Yes, you did.
But I'm not certain. I find that one hard to read. But I don't have anything I totally trust.
And the reason I wanted to ask these questions is Franco's here, and he seems to
Yeah.
have a good background in this.
Hey, no, it's not just my room here. Anyhow, the guy, I have the email is Glenn Elmore and 6GN. I don't know if you know him or not.
Yes. Yes, I do.
Okay, perfect. Okay, so he's the one that was able, and I can forward the email he sent us on June 4th. So he's been able to, and he has a good.
He was successful at doing it.
Yeah,
Getting-
yeah. And actually, let me see whose was here. Oh, you were in. Let me forward you guys this email, Dave's, and then you can take a look.
Okay.
Yeah.
Send that out on the mailing, on the
Yeah,
distribution.
well, yeah, I can send it there too, I guess. I don't know if it's, I mean, I need to look exactly what it says, but yeah.
Hey, back to Scotty. Does anybody know if he monitors any amateur radio repeaters down in the Phoenix area? I'm only about 130 miles from him.
Yeah, we could send you down there.
It's warmer than you know what, but
You would.
if it's absolutely essential. No, I was just wondering if we could get him on one of the repeaters down there or something. I
How
don't know
about
if
a packet bulletin board?
possibly. I'm not familiar. Those are
Well,
there
there's
aren't too
also,
That's a
many-
little dated, but
yeah, there are not too many of those left.
there's also the US mail. I mean,
Yeah.
we can write to them,
Yeah.
Send a radiogram.
but maybe nobody knows what his address is. Maybe he doesn't have an address right now.
The radiograms are delivered by phone mostly, and if he's having trouble with his phone,
Yeah. Hmm.
Well, his
Okay.
phone works well if he's out driving around. And the day I called him, he was like going to the grocery store or something.
yeah, just got to catch them in the grocery store.
Yeah, well, how often is that?
The irony of this, an amateur radio operator that you cannot get a hold of using any
Yes.
technique,
Hmm.
except the US mail.
Pony Express.
Get hold
Yeah,
of him once, I set up a SCAD.
Yes.
Maybe this was by design.
Well, he is also very busy with the house.
now is he still working?
Sort of.
Okay,
He still has a business, but they sold the building the business was in. He sold his previous house, which had a shop that he was working in. And he's living in a travel
Mobile.
trailer on the side of the new house.
well,
And he's dealing with contractors daily.
Ooh,
yeah, right.
Hmm.
That's the story I got from Dan.
Yeah, he's what? He's a KA2,
WA2,
WA2,
Yeah.
EFI,
Echo Foxtrot, India.
Delta Foxtrot, India.
Delta Foxtrot, India. I'll try.
And as I said, I will try again later this week. I've got a lot of things I'm juggling, but I will try again once I get my paper submitted. Which I'm happy to report. While we were on, I did a word count of the paper, and it looks like I'm currently under word count by like 250 words. So I may be able to just add my table tomorrow and call it a day,
Yes.
which would be very nice. I do
Good
not
luck.
want to shorten that thing.
Good luck on that.
Yeah. And I will also be getting in touch with Majid and the Scranton team this week and follow up on where they are with things with the RX-888 as well.
Oh, a couple of things I wanted to bring up quickly. One, when I ordered the RX-888, I noticed that they also have a few antenna preamps available, different types. So I ordered those to evaluate, Nathaniel, so that we can check out our antenna options.
Okay.
The other thing is I just noticed on spaceweather.com that the sunspot number is the highest it's been since 2002.
Wow.
Yes, it is.
So here we go.
Yeah. Exciting solar cycle so far.
Yeah. I mean, I haven't seen a good aurora here in New Hampshire in that whole period. I'm looking forward to the possibility of having them back again.
Yeah, that'd be good.
The Southern boys never seen one.
Yeah, well, they may point out that back then was the, what did they call it, Halloween flare of 2003 that actually did
A
create
Halloween
that
storm.
aurora all the way down to Texas.
Yep.
Yeah. And when I was at Virginia Tech, there was a storm that was seen down in Blacksburg. Saw aurora down there.
There was actually a July 4th, now that I think about it. This would have been several cycles ago. But there was a July 4th here that we had just gotten home after, gotten to a friend's place after watching the fireworks. And then someone came in later and said, oh, by the way, there's aurora. And so we went out to a nearby hill and watched aurora for the rest of the night. And that was one that had the deep red oxygen aurora that made it all the way down to Texas.
Nice, nice.
That would have been probably 40 years ago, but
Yeah.
who's counting?
It's almost 10 o'clock. Before we go, Bill, did you want to say anything about the digital RF, or do you have a question or?
Well, no, Joe was just asking about it. Joe, when you were talking about, you kind of commingled your discussion of the RX-888 along with data collection. So whatever we're talking about here is data collection with the grape, not the RX-888. I mean, eventually we're going to want to do the RX-888 on the road a bit.
Yeah. Well,
Okay, understand. And I
So
just happen to have an 888 to experiment with.
well, the Scranton team, and this is something I'm supposed to touch base with them. There are people on the Scranton team who are supposed to try to get digital RF working with the RX-888 in the same format that the grape is doing. So
Very
I will
good.
find out how they're doing when I get back on Wednesday, I guess.
How
Yeah,
does one get a signal from the 888 into the Raspberry Pi? Same way as the Grape One?
Well, no, not well. It's close. I mean,
It's
the
via
888 has the
USB, right?
USB output.
Yeah.
And
Okay.
then you can actually, with a little clever manipulation, you can make GNU Radio read that USB. Now, I have a feeling there might be a little bit more to it than that, because you got to select out the slice of data you want to look at, And I don't know if the modules in GNU Radio are capable of doing something that sophisticated. It might be, but there might be another piece of software that goes in between. But it's mostly going to be a matter of software, I think.
And I also wanted to add, so I was discussing about that before I went to CDAR. So the one thing that I wasn't sure about with the Radio D program and K9Q radio, so it has options to give you different sorts of demodulation. One of those options says IQ. So I was wondering if that is what generates the receiver slice, is that IQ option. So you get a receiver or a bandwidth slice from Radio D using the IQ option. If that's the case, then you could take that IQ slice and write it to a file. Then what you do to get it into GNU Radio is you have it read from those files in a batch sort of manner. So what you would do is you would create a batch of files, say hours long or day long or whatever, and then you have GNU Radio read from that batch and just process one file and then output digital RF and just keep on going. Now, from what I understand, Bill, the data products that you get from the digital RF, so you get the spectrograms, which show the carrier baseband, and then from what I understand, you get plots of signal amplitude, and also of frequency, like we get from the current grape. Is that my understanding?
Well, digital RF just stores, it's just a way of storing the IQ data. So there are utilities that will give you spectrographs and whatever plot you want, but really it's however you want to process your IQ data and whatever plot you want to make out of IQ data, that's what you can get.
Well, but from what I understand is that there was some Python script or something that will take the great digital RF data and generate the spectrograms and also generate the Grape One data products as well. That's from what I understand. Is that?
Yeah, I mean, I've written such a program that does that. And Kong is working on making some updates to it, some upgrades to it.
Okay, all right. So then
we're going to have something that will do that.
Right. So then,
one question I have for you, Bill, is the bandwidth going to be sufficient that people are going to be able to send the digital RF data up to you in near real time, or are they all going to need an SSD to buffer things?
Well, it depends an awful lot on what kind of upload speed their internet service provider provides. I know. I mean,
10 megs.
In the system that you're operating right now, are you running it in with an SSD?
You talking to me?
Yes, because you are running a digital RF grape right now, right?
Yes,
Yes.
I'm writing the data to a high-speed external hard drive.
Right. So the answer is yes.
It has a RAM buffer, so you can spit the data out to it mighty fast.
To the external hard drive has a RAM buffer?
Yes.
Okay. So I guess my point there is to Gary, when we're doing the pricing, we need to include the external hard drive and the SSD. The good news
wants to be a Western Digital Purple series because it has 100% duty cycle.
Now, we did budget in the original budget for the Grape 2s. There is a line item for each Grape 2 that includes an external SSD. So that's another thing that would be reusable from doing this digital RF Grape 1 to the Grape 2. So that should be coming from John's original budget, not from that supplemental budget for getting the grape ones out.
Yeah, I have been using a spinning hard drive rather than a solid state drive because a solid state drives have a limit on write cycles.
Right.
They wear out. So
Right.
I've been running this spinning hard drive continuously for over a year and it's fine, but I have worn out a couple of solid state drives.
And and this is the Western Digital purple one you said.
Right.
You know how much that costs?
It was I'm wanting to say around $100, and then you need an adapter that it goes in.
So we're talking probably about $150 to $175.
Probably a good idea to look into those prices because those prices are years old. I bought this a couple of years ago. It might be different now.
How big was that drive, Bill? How big?
I think it's a 4 terabyte, but you don't need it to be that big. That's just what they had on Amazon.
You spoke of an adapter?
Yeah, Western Digital uses a SCSI interface, which of course the Raspberry Pi doesn't supply. So you plug it into that and it adapts it to USB.
Thank you.
I didn't know SCSI was still being used. Wow.
That takes me back too.
Goes into whatever goes. Yeah, I mean the standard thing that goes into your
Serial ATA.
Yeah, you're saying it's a current type hard drive interface.
Yeah, current hard drive interface.
Oh, okay, serial ATA.
Maybe I've misstated it, but it's you could plug it into your computer, but you need an adapter to plug it into a Raspberry Pi.
So
like an external case or something.
Right.
Gary, I can tell you in the original budget for the grape project, we budgeted for $270 per grape for an SSD. So I don't know if John has been able to stick to that original budget, but that's what was originally budgeted. So
what's your, yeah. Go ahead.
And actually, I don't know if you've ever seen this, what do you call it? This spreadsheet, Gary, but I'll email it to you now. This is what we had originally made the cost estimate for the Grape 2.
So that Western Digital Purple series, is that the SSD or real hard drive?
The spinning hard drive. It's $84 on Amazon.
Nice. For 4 terabyte?
Yes.
Yeah,
Wow.
they're designed for video surveillance recording.
Right. Yeah, so they'll run 100% duty cycle with no problem.
That's good to know. Yeah.
And the adapter usually is 20 or 30 bucks generally.
Yeah, I've got those. We do that all the time. We fill up terabytes routinely.
Yeah, I mean, these are available in much larger sizes
Right.
If you need something.
But I'm just saying that yeah, our AM Doppler, we're just using 256 gig solid states, but
Yeah, I mean, after you upload your observation to the central system, you could delete it, but I've just been keeping them. So I got many months of them, and it hasn't hard drive even breathe hard.
Yeah, with our research, we swap drives. We send up new drives and have them send the old ones back.
But yeah, thanks for answering my questions. That was just something that I just wanted to understand. I would work on this too and get it working, but I have so much the VLF backlog stuff to do, you know, that I'm unable to do it. But I wanted to at least have it in my head and understand exactly the signal flow, because I often have to do that with VLF, but Yeah, I think what I mentioned, currently that's what would work right now. I don't know if anyone is working on that, or if anyone talked to Phil Karn about the IQ option in Radio D, and what that actually does. I don't know if anybody talked to Phil about that, but if that is an option to output a lower frequency, a lower bandwidth IQ slice, then that would much reduce your requirements for a disk.
I
And
see Franco is asking what's the actual bandwidth we can get through our Pi? Anyone
Because you're
know?
reading and writing, so you need 2x.
What have you done that with the Raspberry Pi, Bill, or what was your processor?
It was, well, okay. We're not doing any 122 mega samples. I think mine is running on the Grape, which is taking 8 kilosamples per second. That's it.
Yeah, that's not the same thing.
Yeah, so you know,
Yeah, we'll have to check on it. We're doing some pretty high data rate on Pis, or similar, using USRPs and RSP duos, things like that, direct sampling. But I'm not sure what our actual data rate is. It's more down in the 10 mega sample per second, I think.
and the other thing, if you're storing in digital RF format, even the lowest level of compression cuts the data by more than 60%. So you don't have to write at the same rate as you're reading.
Right.
Yeah, but then you have to take into account the CPU to compress it.
Yeah, on the Raspberry Pi, again, it depends on how much bandwidth you're trying to save.
Yeah,
we shouldn't.
that's why we discussed it with John. Yeah,
we shouldn't try and make the Raspberry Pi do the job of a high-end desktop, because if anybody's trying to do that, it's not gonna work. No, all we're trying to do, well, at this point in the project, all we're trying to do is just get samples around a few key WWV frequencies. Now,
okay.
In the future, of course, yes, it would be nice to digitize 60 megahertz wide, the whole spectrum, DC to daylight, or rather 0 to. I'm not sure what you're going to do with all that data, but we're not ready for that yet.
Okay.
well, and so that's why that I'm hoping that IQ option in Radio D can give you, you can choose how much bandwidth you want. So you could choose a bandwidth around the WWV frequencies, and then you could have data rates and data products similar to what you have with these with the Grape One sound card input, where you just downmix the baseband in GNU radio, and that would reduce your requirements. So at least for a start, downmixing to baseband makes sense for this. I mean, if you want to capture everything, but what you would do is in the signal processing chain, instead of writing to disk, you just have everything done in memory first and then write to disk. Because that's how I do it with the VLF stuff. All the signal processing is done in memory, circular buffers, and then things are written to disk.
Right. The GNU radio flow diagram that I have, it will save 2 streams at the same time. One is 8 kilohertz wide, and one is 10 hertz wide. And I turned off the 8 kilohertz wide one, because if all we want to do is look at WWB Doppler shift, all you need is the 10 hertz wide one, which is, you get that at 10 samples per second. So it's
right.
Atari 800. So
I mean, First of all, if you need only 3 channels or 4 channels, you can do X-lating, filtering, no radio, 3 of them, and you're good to go. You don't need to do a K9Q radio, because for those, few 5, 6 channels, you can do that, and a bunch of fairs and go with that. I mean, at least that's what I'll do for that. For the eclipse, since it's one of lifetime events, I thought you may want to have the whole spectrum say to this, because 3-hour spectrum, and then later on, Nathaniel, everybody can play with it to their heart content. I mean, that's all it.
Yeah, it's probably a good idea to do just that, but probably not with a Raspberry Pi. Probably with a high desktop.
Actually, I think if you don't do any processing, even an i5 or something like that will be enough, because you need the bandwidth to go back and forth. Don't even think about what the samples are. Just dump into disk and be done with it.
Yeah, right. Yeah. And when you're writing, you could put a hard drive right in the computer and not even bother the USB with it.
Well,
Yeah, exactly.
Hard drive in the computer.
Like an NUC or something like that, and now they throw away for nothing.
Well, for the after the eclipse, what you can do is if, let's say, for example, Radio D, its current implementation doesn't output a smaller bandwidth IQ slice. What you can do is you could write data into the Pi's RAM drive, and then have GNU Radio read the files and then clear everything out, or have a separate script to clear everything out, and then everything's done in RAM drive for the full bandwidth files. If Radio D doesn't work, and then you could have the smaller size data products.
Yeah, honestly, John, for the eclipse, I think we should follow the KISS principle, just right, because, you cannot afford to put too much stuff and risk losing stuff because ignore it or something is problem. But once you have the files, and then you can do whatever. And you can do 25 times after that. And if it breaks, no big deal. But the eclipse itself, I think it's safest to just dump it and be down, and have that to play with.
Right. I meant after the eclipse. So
yeah, okay.
Yeah. And then I have my VLF system. So my VLF system for the eclipse, it's recording raw spectrum right to the hard drive.
Yeah.
So then
that's
yeah. And then once, so I'll have a spectrum recording for the VLF, and but once the eclipse is over, to get some smaller size data products and lessen the requirements in the hard drive and people's internet bandwidth and server space and all that, just to keep everything down but still have the valuable data. Again, I would help, but I just don't have enough bandwidth.
Ha. What if you increase your sample rate, Jonathan?
I might overload the processor.
Well, I think it's 10:20. It's gonna be the 4th of July. I think we should call it a night for today. And hope everyone has a wonderful 4th of July.
Go shoot some fireworks.
That sounds great. Thank you. I think we're going to the water park tomorrow.
Happy 4th, 73.
73, everyone. Thank you.
Everybody.
23.
73.